Conditional probability part 2. Probability part 2. In this video we will look at some typical exam style questions. So let's have a look at some more examples. In the following slides, the Venn diagrams or tree diagrams will have been completed for you. In a test, however, this will normally be asked of you first. You would then use your completed Venn diagrams or tree diagrams to calculate the probabilities. Note, you can always use the formula to get to an answer quickly, but I like to visualize what is going on in each case. This is more important when dealing with tree diagrams. So the first question, 120 pupils took a selection of subjects. 48 took geography, 50 took history, 23 took both history and geography. This information is shown in the Venn diagram. Find A, the probability a student took history. Well, that is 27 plus 23, which is 50, out of 120 students. B, the probability that a student took geography knowing he took history. Well, this is out of 50, the number who took history. And those that took geography is 23. So the probability of a student taking geography knowing he took history is 23 out of 50. The probability that he doesn't take history knowing that he took history and or geography. So this is out of 23 plus 27 plus 25, which is 75. Then those that didn't take history is 25. So the final probability is 25 out of 75. Note that you could simplify both A and C. In an exam, you would normally do this. In this question, the probabilities are already given. Follow the same approach. Find the probability of B given not A. So not A is 0.1 plus 0.05 plus 0.15 plus 0.3, which is 0.6. Now the probability of B is 0.3 plus 0.15. So the probability is 0.45 divided by 0.6, which is equal to 3/4. The probability of C given A intersection B. So A intersection B is 0.2 plus 0.05, which is 0.25. And now the probability of C is 0.05. So the probability is 0.05 out of 0.25, which is equal to 1/5. The probability of B intersection not C, given that A union C. So first find A union C, which is equal to 0.6. Now find B intersection not C, which is 0.2. So the probability is 0.2 divided by 0.6, which is equal to 1/3. You are told that the probability of A is 2/5, the probability of B is 1/6, and the probability of B given A is 1/8. Find the probability of not A intersection B. Which is that part. We need to start working out some probabilities using the given that statement, A has happened. Let's ignore everything else. So we concentrate on circle A. Let X be the intersection of A and B. Then the probability of B given A is out of 2/5. Remember that now the total probability is out of 2/5. The probability of A, given that A has happened. X is the numerator. The only part of B left. What is the probability of B? Well, that is equal to 1/8. You are given that in the question. We're now going to solve for X. So X equals 2/5 times 1/8. So X is 1/20. Note that you could have found this straight away by using the formula. The probability of A intersection B is equal to the probability of A given B times the probability of B. So X is 1/20. So the probability of not A given intersection B is 1/6 minus 1/20, which is equal to 7/60. In this question, the probability of B is 1/4, and the probability of not A given not B is 1/7. Work out the probability of not A intersection B. Given that B doesn't happen, note that the probability of this is 3/4. The probability that A doesn't happen is 1/7. The only section left is not A is on the outside. Let's call the probability of this region X. So X over 3/4 is equal to 1/7. So X is equal to 3/4 times a seventh, which is equal to 3/28. Again, we could use the formula, but sometimes it's easier to visualize what is going on. So we could have used the probability of not A intersection not B is equal to the probability of not A given not B times the probability of not B. While you can always use logic to visually decode questions like this, it is often easier to just use the formula, especially for more complex questions. This is not always the case, however, for tree diagrams. The performance of a cyclist in a race is affected by weather. It rains or not that day. The probability that the cyclist crashes is 7/12 when it's raining and 1/12 when it's dry. On any given day, the probability of rains is 1/5. What is the probability it was raining given the cyclist crashes? As there are multiple dependent events, we would need to construct a tree diagram. The performance of a cyclist in a race is affected by rain or not that day. The probability that a cycle crashes is 7/12 when it's raining and 1/12 when it's dry. On any given day, the probability of rains is 1/5. What is the probability it was raining given the cyclist crashes? Right, so rains is 1/5, dry is 4/5, crash is 7/12, so no crash is 5/12. If it rains, if it's dry, crash is 1/12, no crash is 11/12. First, calculate the probabilities of all outcomes. These are the only values we can use. So we got 7/60th, rains and crash, 5/60th, rains and no crash, 4/60th, dry and crash, 44/60th, dry and no crash. Given the cyclist crashes. So there are two events where the cyclist crashes. 7/60ths and 4/60ths. One when it rains and one when it's dry. We can ignore the other outcomes. So ignore those probabilities. So it is out of 11/60ths, given the cyclist crashes. What is the probability it was raining? Well, that's 7/60ths. There is only one time when it rains and he crashes, and the probability that that event occurs is 7/60ths. So the probability is 7/60ths out of 11/60ths. Which is 7 out of 11. Summary. When dealing with given that questions, remember to only consider what has already happened. This reduces our sample size. Fractions are often the best and most accurate way of leaving an answer. Make sure your knowledge of Venn diagrams is spot on so you know which regions the questions refer to. Find an approach that works best for you. If that is simply to use the formula, then just use the formula. But make sure you check your answers to see if they make sense.